Welcome to our last lesson of the unit, and good news, we're not going to be covering any new methods for solving. We covered all the methods that we need. Today we're going to focus on how do I know which method to use in different situations, because we did an entire lesson on substitution, an entire lesson on graphing, an entire lesson on matrices, etc. But how do I, and it's easy enough for me to say in directions, do this by substitution or do this problem by elimination. But if you're just out there trying to solve a problem and I let you choose any one, how do you know which one is the best to use? I kind of referenced this in the first lesson about we'd spent some time on recognizing which method is best in different situations, and that's what we're focusing on today. So you've really got a few options here. The three basic ones are graphing, substitution, and then elimination / matrices. Now, the reason these are together is because the two are kind of interchangeable. Y'all heard me last time talk about how much I love matrices. If I have to choose between elimination and matrices, I'm choosing the matrix every single time. But they have the same basic setup. That's why they're in the same box there. Okay, so when would you use graphing? Well, graphing is going to happen when both equations are in slope-intercept form. They've both got y equals mx plus b. So right here, slope of 2, y-intercept of 4, slope of -1/2, y-intercept of -2. I would graph in that situation. When would I use substitution? Well, when I've got one variable isolated. Okay, now here's what I mean by that. Here I've got this x equals. When I got one variable isolated, I'm jumping over to substitution. Now, elimination or matrix, when am I going to use? Essentially, for me, it's every time. But for practical purposes, though, it's whenever both are in standard form. So you can see here I've got ax plus by equals c, ax plus by equals c. They're both set up that way. Okay, now which one would be best for these? Again, we're not going to solve, we're just going to go through and label them. Okay, number one, I've got standard form on top, standard form on bottom. That one in my mind is going to be a matrix problem. Okay, number two, I've got slope-intercept on top, standard on bottom. Well, that means I've got one isolated, so that is a substitution problem. Okay, number three, y equals, slope-intercept on both, that is graphing. Number four, y equals, again, slope-intercept on both, that's a graphing problem. Okay, number five, looks like I've got standard form on top and slope-intercept on bottom. Again, I've got my y equals there, one variable isolated, that is substitution. Number six, standard form on top, standard form on bottom, that's going to be matrices. Okay, seven, standard form on bottom, y equals on top, that's substitution. And number eight is standard on top, standard on bottom, that's going to be a matrices for me. Again, you could put elimination there if you really wanted to. But let me see, of all these, actually of all of those, the only one that really lends itself well to elimination is number 6, and that's because of my coefficients of 1 and -1. So this one would be a good candidate for elimination if you wanted to. Okay. Number 9. History test has 30 questions worth a total of 250 points. Okay. Every question is either multiple choice or true false. Okay, so it looks like my two different values I'm going to have here are multiple choice and true false, M and T. Okay, the true false questions are worth 5 points each. Multiple choice questions are worth 10 points each. So it looks like those are my rates. So let's see, 5 times true false. Let me get a better T there. So 5T plus 10 for multiple choice equals looks like my total is 250. Okay, now what about the second equation? Well, it tells me that I've got 30 questions. So that means multiple choice. Well, I'm writing the same order. I put T first. True, false plus multiple choice equals 30. Okay, now, which method am I going to use here? Looks like I've got standard form for equation 1, standard form for equation 2. So I'm going to use a matrix for these because I've got standard form on both. So let's go ahead and write our matrix out. First equation is 5, 10, 250, 1, 1, 30. Now I'm going to go ahead and set up my RREF matrix and then jump over to the calculator. If my calculator will turn on. Okay. So now I'm going to go to second matrix, arrow over to edit and select A. Make sure my dimensions are in there because they're not in there this time. 2 by 3 and 5, enter, 10, enter, 250, enter, 1, 1, and 30. Okay, back to the home screen. Go back to the matrix menu, over to math, find option B. Back to the matrix screen, select matrix A, and I've got 10 and 20. So let's see, I had T first, so true, false, there are 10. Multiple choice, there are 20. So actually, I probably better write that here. True, false questions are 10. Multiple choice are 20. And then answer to the question asked. That's really important, guys. I can't phrase this enough, but make sure you're reading through which system of equations can be used to determine how many multiple choice questions M and how many true, false questions T are on the test. Well, you know what? It's the same thing here. So there are 10 true, false questions and 20 multiple choice. You got to make sure you're reading the question and answering the question that's being asked of you, not the one you're thinking in your head. Okay, Sally and her friend Lucy started saving money to buy a new iPhone. I guess that P should be capitalized, shouldn't it? Could be proper here. Okay. Sally started with $150 and plans to add $5 to the total every week. Lucy started with $200 and plans to add $3. When will they have the same amount? Well, it sounds like my W for number of weeks is going to be one of those. Oh, and the amount saved. Don't take the bait and say that Sally and Lucy are variables. They are people, not variables. And so we got W for number of weeks and A for the total amount. So it looks like I've got a starting value of 150 and then a rate of 5 for Sally, which means that I'm going to have a slope-intercept style equation that's going to be the amount equals $5 times the number of weeks plus 150. Okay, now if you look at Lucy, you've got the exact same idea. So her amount is equal to, let's see, $3 times the number of weeks plus 200. Okay, now what method is best for this one? Now, what we talked about earlier at the top is that when I have two slope-intercept forms, that is going to be a graphing style problem. There's only one problem with this. With these numbers being so large, if I go and put that on the graph, it's not going to be easy for me to graph it. So one alternative here, when you have both of them in in slope-intercept form, is to do a substitution. Now, the way we're going to do that is I've got A equals on both of them. So let's take this equation here at the top. A equals 5W plus 150. what if I substituted in for A? And what if for A, I plugged in all of this? Because A equals 3W plus 20. So what if I put over here 3W plus 20, or sorry, 200? Okay, now those parentheses aren't really needed. So I could just solve that. So I'm going to use substitution on this one, yeah. Okay, so let's see. I need to figure out which one's bigger. The 5W is bigger, so I'm going to subtract 3W on both of them. And that's going to leave me with 200 equals 2W plus 150. Now I'm going to subtract 150 on both sides. And that's going to leave me with 50 equals 2W. Now, I'm running out of room here, but let's divide both sides by 2, and that gives me W equals 25. Okay, so the solution here, well, we're going to go ahead and plug back in for my substitution step. A equals 3 times plus 200, and I'm going to plug in my 25 there. So A equals 3 times 25 is 75 plus 200. So A equals $275. So the solution happens at the point 25 to 75, where 25 is the number of weeks, 275 is the number of dollars. But what question is being asked? When will they have the same amount? Well, when is just the number of weeks. So after 25 weeks. Okay. Number 12. Mr. Wang can eat 4 times as many brownies as Miss Easter. Okay, so if they eat a total of 35 brownies, how many does each one eat? Okay, well, in this case, I do believe that Mr. Wang and Miss Easter are going to be the variables. So if I was to write that, well, I'm going to have Mr. Wang and Miss Easter, so W and E. Let's see. Wang equals 4 times Miss Easter. Okay, now if they eat 35 brownies total, so Wang plus Easter is 35. Well, I've got standard form for equation 2. I've got slope-intercept for equation 1. That is going to be a substitution problem. So we're going to rewrite this equation, but we're going to replace the W with parentheses, and I'm going to substitute in the 4E. Now we solve. 4E plus E is 5E equals 35. Now let's divide by 5, and that's going to give me that E equals 7. So I'm now going to plug back in W equals 4 times 7. And so W equals 4 times 7 is 28. All right. So how many does each one eat? Well, my solution here is 28, 7. And that means that Mr. Wang eats 28 brownies and Miss Easter eats 7 brownies. Okay, last problem. 2 small pitchers and 1 large pitcher can hold 8 cups of water. The large pitcher holds twice as much as the small pitcher. How many cups of water can each pitcher hold? Okay, so our variables, looks like we got small pitchers and large pitchers. I'm going to use the L because of, I don't want my L to look like a 1 on accident. Okay, 2 small pitchers, so 2S, and 1 large pitcher can hold 8, so 2S plus L. The large pitcher holds twice as much as the small pitcher. So L is equal to 2S. Again, one standard and one slope intercept. That means I'm going to have a substitution problem. Okay, so we're going to write here 2S plus L equals 8. But instead of L, I'm going to substitute in my 2S. So 2S plus 2S gives me 4S equals 8. Divide that by 4 gives me S equals 2. Now, I'm going to substitute back in over here. L equals 2 times, here S is 2. So my large pitcher, L equals 4. So again, my solution happens at the point 2, 4, but the question asks how many cups of water can each pitcher hold? Well, a large pitcher holds 4 cups, and a small pitcher holds 2 cups. So there we go. Again, feel free to reach out to me. We're going to have our test review next class period, and then we will be doing our test on the, I guess, 2 blocks from now.